Welcome to the section on soil shear failure. The learning objectives for this section are first, to be able to understand the different soil shear failure checks for what we're considering uphill and downhill sliding. Second, to understand the modes of failure for soil underneath the abutment. Third, to apply engineering judgment to make conservative assumptions about the failure modes. And fourth, evaluate your site and determine what soil analysis and further testing is needed. So this check is another check we can perform that becomes relevant with, or more relevant with, custom abutment design. A soil element can fail under normal stresses or shear stresses. So the normal stresses or principal stresses on a soil element can be either compression or tension. And in this case, we'll refer to as compression as positive and tension as negative. And shear stresses are either going to be in the clockwise or counterclockwise direction. And I've drawn out here, just as an example, a more in-depth soil analysis on a soil element can be done using Moore's circle. This is a great analysis tool, and I've attached an excellent 10-minute refresher video below this so that you can learn more if you haven't already taken a course in which you've done this. I'm not going to go in depth about Moore's circle and using Moore's circle and all of those things, because that is going to frankly be beyond the scope of the checks we are doing. In the following sections, I'm just going to go through a basic check that we use to analyze soil shear failure, and it's basically a flag or a trigger for us to think, okay, do we need to sharpen the pencil on this check? Do we need to do an advanced analysis, a further analysis of failure modes, the failure angle, and soil properties may be necessary if we're failing our basic check and there isn't a way through design that we can pass that check. So in the next section, I'll go into the uphill check for soil shear failure.